So hi and hello. Welcome to our channel named Algo Exploration. My name is Samir. Now in today's lecture we are going to find that how to count the longest consecutive sequence in a given unsorted array. So here is an example. So we have an array. Inside this we have 100, 1, 4, 200, then 3 and 2. Now we need to return the length of a longest consecutive element in a sequence. Okay, so if we take a look of the first element, which is 100, okay, do we have 101? No, so just ignore it. Now here the element is 1. Okay, so now we need to search for 2. Do we have 2? Yes, we have 2. Then again search for 3. Yes, we do have. After 3, 4 is there, right? So here till now we found the longest consecutive sequence is 4. Okay, now let's go for another element. For 200, do we have 201? No, we don't, right? So at last we need to return the length of a longest consecutive element in a sequence. Okay, so it's a lead code problem, so in the description I'll give you the link of this problem. Okay, so let's see that how we can solve this problem. Okay, so as usual, the approach one or the brute force. Okay, so here if we take same array, what we can do, okay, first of all we can try to sort this. So it will be 1, 2, 3, 4, 100 and then 200. Okay, now after sorting, what we can do, starting from the first index element, okay, we can try to compare it whether the previous element is -1 or not. If it is, move further. For 3 it is -1, or that means 3 minus 1, that is 2, it is consecutive. For 4 also we can do it same way. Okay, so till now we found the length of this is 4. Okay, now let's, if we move further, again we are going to try to check whether the previous element is -1 or not. Here we can see that the previous element is 4. Okay, so we are going to break it and we are going to start from here now. Okay, similarly we will go for 200 as well. Okay, so first we are going to sort it. So sort an array. Okay, then initially the count will be 1. Okay, now using the for loop in which I will be running from 1 and it will be gone till n. Okay, we are going to compare with its previous element. If a of I is equals to a of I minus 1 plus 1, if they are equal, that means the previous element is less than 1. Okay, so we are going to increase our count. Otherwise, if they are not equal, okay, that means the previous element is not less than 1, so else here we are going to have answer equals to max of count comma answer, and then we are going to initialize the count again to 1 because we found the new series or a new sequence. Okay, so this is the brute force approach, and at last after this end of this for loop we are going to return the answer. Okay, now if we take a look that what will be the time complexity of this approach. Okay, so here we can see that we are sorting in an array first. Okay, so if we uh, sort it using the merge sort or the quick sort, okay, so it will take n log n time. Okay, and for this it's a single for loop that will take n time, so the time complexity will be n plus n log n, that will boils down to order of n log n. Okay, and what will be the space complexity? See, if you sort this array using the merge sort, then obviously the space complexity will be order of n. Okay, but if we sort it using the quick sort, then it will be constant. So if we sort it using the quick sort, it will be constant amount of time, constant amount of space. Okay, so here we can see that the time complexity is huge. Okay, so we need to optimize this. So approach 2. So let's take the same example here. Now, what if we store all the elements in an hash set first? Okay, how can the solution will be optimized? See, if we are starting from here, okay, in the hash set, okay, we can check whether 2 is present or not in a single shot. That means in a constant amount of time, we can check whether the 2 is present. Okay, after that, in a constant amount of time only, we can check whether the 3 is present as well as 4. Okay, so here is the little bit of optimization. So this is an hash set. Inside this, we are going to store all the elements. Okay, now see, here is what I'm trying to say. If we start with the first element, that is 100, okay, after storing into the hash set, we are going to check whether 101 is present or not. It is not present, right? So the length of this sequence will be 1. Let's move further for element 1. Here also we are going to check whether 2 is present. Yes, it is present. Then move forward. 3 is also present. Move forward. 4 is also present. Move forward. Check for 5. Here we can say 5 is not present. Okay, so the length of this sequence will be 4. Again, move further. I'm standing at 4. Now for 4, okay, I'm going to check whether the 5 is present into the hash set or not. I can see that 5 is not present. Okay, so the length of this sequence will be 1. Move further for 200. For 200, I'm going to check whether 201 is present or not. Okay, I can see that 201 is not present. So simply the length of the sequence is 1. Again, for 3, I'm going to check whether the 4 is present into the hash set or not. Yes, it is present. Go further. 5 is present. No, 5 is not present. Okay, so the length of this sequence will be 2. Now again, I'll move further for element 2. For 2, I'll check 3 is present. Yes. 4 is present. Yes. 5 is present. No. No. So the length of this sequence will be 3. Okay, and then we are going to store this largest element, which is 4. Okay, so here in this way we are going to solve this approach. So the pseudocode will look like this. First of all, we are going to create the hash set and populate it. So create hash set and populate. Okay, now using the for loop in which I will be running from 0 and it will be gone till n. Here the initial value will be a of I. After that, let's take k as 1 to keep the count of the sequence. Okay, while I'm going to check h set dot contains initial value plus k. If that element is present, I'm going to increment the count. Okay, if this is failing, then the answer will be max of answer comma k. That's it. Okay, so this is the approach. Let's try to dry run this code so you will get a clear picture. Okay, so first of all, I have populated this hash set. Okay, now I is pointing to 100. Okay, so the initial value is a of 0, that is 100. Okay, value of k is 1. Okay, I'm going to check whether hash set is containing initial value plus 1, that is 100 plus 1, that is 101 in the hash set. I can see that 101 is not present. Okay, so I'm going to move further, but I just forgot answer will be 0. Now there will be a comparison between answer and k. Okay, I got to know that 0 is lesser than 1, so I'm going to update it to 1. Now let's move further. I will be pointing to 1 now. Okay, initial value will be 1 and the value of 1 and the value of k is 1. Now I'm going to check using the value where initial value plus k, that means 1 plus 1, that is 2, is 2 is present into the hash set. I can see yes, 2 is present. Okay, so I'm going to increment the value of k. Okay, and then I'm going to run into loop only. Now the value of k is 2 and the initial value is 1. Okay, so 1 plus 2, that will be 3. Again check whether 3 is present. Yes, 3 is present. So increment the value of k, that will be 3. Check again whether 1 plus k, that is 3, whether 4 is present into the hash set. Yes, 4 is also present. Okay, so again increment the value of k to 4. Now check whether 1 plus 4, that is 5, is 5 present into the hash set. No, it's not. Okay, so I'll be running out of the loop and I'm checking, I'll be comparing which one is maximum, previous answer or the k. I can see that here k is maximum, so I'm going to update it to 4. Okay, then I'll be moving forward in which the value of I will be 2 now, which is pointing to 4. So the initial value will be 4 and the value of k will be 1 now. Okay, now check using the while loop whether initial value plus k is present into the hash set. I can see that 4 plus 1, that is 5, is not present into the hash set. Okay, so I'll not go inside this while loop, simply I'll run this statement. Here we can see that previous answer is 4, now the value of k is 1. Which one is maximum? 4 is maximum, so I'll not update. Then I'll move forward in which the value of I will be 3, which is pointing to 200. After that initial value will be 200 and the value of k will be 1. Okay, now check using the while loop whether the initial value plus 1, that will be 201, is present inside the hash set. No, it's not. Okay, so again I'll not go inside this. Okay, simply I'll compare previous answer and the value of k. I can see that previous answer is greater. Okay, so I'll move further. Value of I will be 4 now. Okay, which is pointing to 3, so the initial value will be 3, value of k will be 1. Using the while loop I'll check initial value plus k, that is 3 plus 1, that is 4, is 4 present into the hash set. Yes, we can see that. So go inside the while loop and increment value of k, that will be 2. Now again check whether 3 plus 2 is present inside the hash set. We can see that no, 5 is not present inside the hash set, so we'll not go inside this and we are going to simply run this statement. So 4 versus 2, we can see that 4 is greater. Okay, so we'll not update it. Now let's move forward. I is pointing to 5, so the initial value will be 2, value of k will be 1. Using the while loop I'll check initial value plus 1, that is 3, is 3 present inside the hash set. Yes, we can see that 3 is present. Okay, so increase the value of k, that will be 2. Again run initial value plus k, that leads to 4. Whether 4 is present? Yes, 4 is also present. Again increase the value of k, that will be now 3. Then check initial value plus 3, that is 5. Whether 5 is present inside the hash set? No, it's not. Okay, so we'll not go inside this while loop and simply we'll compare whether which one is greater, 4 or 3. We can see that 4 is greater, so I'll not update and I'll move forward. I is pointing to 6, we can see that no elements is present, so we will be terminating this loop. Okay, and we are going to simply return answer. That will be 4. So I hope you got this. Now, if we think about the time complexity, okay, creating the hash set and populating it, okay, leads in time, okay. This for loop is taking n time, okay, but what will be the time complexity of this? Okay, this will also take approximate of n time complexity, okay. So due to this nested for loop, it will be n square. So here the time complexity is order of n square, and the space complexity is order of n because of the hash set. Okay, so here we can see that the second approach now it's much greater than the first approach. Okay, now if we take a look, as I always said that optimization always happen by observation. Here we were doing some redundant steps. Okay, at this time when we were standing here, 1 was the initial value, okay, then we were going 1 from 2, then 3, then 4, okay. So we got, at that time we got the length as 4, okay. But when we were standing here, okay, we were considering 2 as the initial value, then 2 to 3, and then 4, and so on, okay. So what if when we are standing here, we will check whether the previous element is already present in the hash set or not. If it is present, we will not consider this 2 as the initial value, will simply ignore and move forward. So that's the optimization here. Okay, so again I'm reiterating, when we were standing here at 1, from 1 to 2, then 3, then 4, okay. Again, when we were standing at 2, we were going to 2 to 3 and 4, okay. So why should we do that? Okay, so instead of taking 2 as the initial value, first we'll check whether the minus 1, 2 minus 1, that is previous element, that is 1, is present in an hash set or not. If it is present, then we will not consider 2 as the initial value. Same goes for 3, same goes for 4. Okay, so here we can see that we are only considering 100, 1, and 200 as the initial value because the previous elements are not present. Okay, so approach 3. And also in an array, duplicate element can also be present. Okay, so first create the hash set and populate it. After that, I will be running from 0 and it will be count till n. Inside this, let's take initial value as a of I and the value of k as 1. Now here I'm going to check if hash set dot contains initial value minus 1. Here if the previous element is present, here I'm not going to mark this initial value as initial value. Okay, I hope you got this. So due to that I'm putting as not. Okay, I hope you got this. If the previous element is not present, then only I'm going to enter inside this if case. So here while HSet dot contains initial value plus k. If it is, then I'm going to do k plus plus. That's it. And then answer is equals to max of answer comma k. But here also someone might say that this for loop is running for n time and so as this while loop. Okay, so yes, perfectly, that is true. Okay, so what we can do to optimize this, instead of iterating into the whole array which can contain multiple elements. Okay, so we can iterate it on the hash set. So here I'll just erase this. Instead of iterating on an array, I'll iterate in on hash set. So int, I'm taking the help of enhance for loop initial value colon hash set. That's it. So now, okay, so this is the code. Now what do you think, what will be the time complexity of this approach? Okay, so you can comment it down. Okay, it's definitely not n square. So that's it from my side. I'll see you in the next video. Till then, keep practicing.